Well, hello humanity. The Earth is approximately 4.54 billion years old, and we're fairly certain that we know what our home planet has looked like in the past, and what it looks like today. But what will it look like in our future? Will our species still be about to see the planet change, and how will the geology of our world shape our distribution in hundreds, even thousands of years from now? It's May 2015. We're all taught in school that the Earth is a spheroid made up of 7 similarly sized continents: Asia, Africa, North America, South America, Europe, Australia, and Antarctica. We generally tend to disregard smaller islands and like to cluster countries like the United Kingdom to be part of larger landmasses, in this case, Europe. The Earth's continents are in constant motion, and although we may not feel it, they're continually moving far below the ground. In 1912, a German meteorologist called Alfred Wegener proposed a theory that continents such as Africa and South America were once joined. He backed this up with evidence by taking soil samples from both continents and illustrated the similarities between them. He found large deposits of coal, which are normally found in climates with high humidity, in regions like the North Pole. This is more than just a coincidence, and it told Wegener that different areas of land must have been in contact with one another somehow in the Earth's past. To us, these continental movements are all but indistinguishable to the naked eye, as the amount of time it takes for such a large amount of land to move across the surface of the Earth is not insignificant, slowing the process to about the same rate our hair grows. For consistency, let's jump back to May 200,000,015 BCE. At this point in our history, our planet looked very different if you were viewing it from space. All the continents were clustered together into one giant supercontinent known as Pangaea. Think of the Earth as a massive jigsaw puzzle. All the continents form its pieces that fit together perfectly if you wind the clock back far enough. Pangaea formed about a third of the Earth's total surface, and was the reason why we've been able to resolve many geological and archaeological mysteries, such as the aforementioned coal problem, and also why fossils from one species can be found on entirely opposite sides of the world. It also answers how some plant species like the Glossopteris were found near edges of South America and also Australia. To cut a long story short, the Earth's continents sit on geological plates that shift and move due to the intense heat and pressure generated below the surface. Subduction zones, areas where plates collide, generate violent tectonic activity and are what cause the drift of the continents to occur. Land is recycled inside the mantle, while new land is churned out elsewhere. Unfortunately, this massive release of subsurface energy has to go somewhere. It often causes earthquakes, which can be as destructive as they are constructive. The process of plate convection below the ground is what causes the continents to move. The Earth's land very literally rolls across the surface of the planet by a process of recycling. But back to the future, and let's jump to May 100,000,015 CE. North America, South America, and Asia have formed a new supercontinent, Amasia. Despite the fact that the continents are moving at such a mind-numbingly slow rate, we can still make a projection based on their current direction of movement and speed, taking into consideration their arrangement in the past to make a remarkably accurate prediction about their position in the future. Throughout the 4.5 billion years of Earth's history, we can say with certainty that there have already been 4 times that all of the world's continents have coalesced to form one super landmass. But so far, each time this has happened, there hasn't been anything remotely resembling human life in existence on the surface of the Earth. This raises a particularly interesting geological and socio-political question that our children could find themselves needing to address in a few million years. Let's suppose we woke up tomorrow and found that the Earth had arranged itself into a supercontinent configuration like Amasia. How would nation-states, sovereignties, and current continental divides continue to define themselves when they very clearly sit right next door to each other? If 2 currently politically opposing countries were to suddenly find themselves sandwiched together, would this improve the situation between them, or make it worse? With a mix of highly developed and highly underdeveloped countries sat on one another's doorstep, would the reality of the third world suddenly become more visible? And, most importantly, would my commute to work be any shorter? Last year, our planet's population reached 7 billion. It can be difficult to predict how population rates will continue to grow or decline in the immediate future, let alone in the distant future, with so many variables that affect human development. In the last 100 years alone, the life expectancy for the average person in a developed country has jumped from around 55 to 85. The United Nations and the United States Census Bureau shows 3 major predictions for our species over the next 85 years. At its most optimistic, the data shows that by 2100 there could be around 16 billion people living on the planet, while at its lowest, government bodies predict that we could decline to around 6 billion. A difference of about 10 billion people who may or may not ever exist seems like quite a large margin for error, but factors such as wars, famine, poverty, booms, droughts, natural disasters, and living standards can all greatly affect the birth and death rates of our species. Our environment is also facing increasing demand to produce food and energy in vast quantities, and overcoming this challenge will largely affect the shape and distribution of humanity across the continents even 50 to 100 years from now. Professor Ossip K. Fletchheim coined a term, futurology, in his 1947 book, Futurology, The New Science. In it, he examines data from a range of environmental, economic, and social sources to construct holistic or systematic models which study the complex systems of nature, with the intention of accurately mapping future events. He focused on long-term predictions, examining possible futures through both assumption and empirical data. Fletchheim's analysis was problematic though, not least because it didn't take into account the lives of individual humans, but also because it stressed a definitive single future instead of multiple potential ones. Modern theories such as Moore's law and cosmic inflation pose multiple outcomes for these complex measurable systems, and as such the evolution of computing and the eventual fate of the universe. While these systems are more measurable, it doesn't make them definite. So why does it seem like we're more certain about them than we are about the distribution and continued existence of our own species on our own planet? Well, no matter how accurate our predictions of the future may seem, humanity is simply a factor that skews data. For most of the deep history of the planet, humankind hasn't existed and nature has been allowed to continue and progress unimpeded, predictably, without us. Every human has the potential to affect the fate of the planet in a multitude of ways, which would seem to make its future and that of our civilization even less certain. These are the kind of things that I want to address on this channel. There's already a handful of new technology, ideas and movements that have been set in motion that may change the future for all of us. For the time being though, we'll still be here on these 7 continents, experiencing as much of that change as we can. To quote Barbara Jordan, for all of its uncertainty, we cannot flee the future. So stick around, and let's see what's coming next.